transient is very important. Only one question you will get it, but that question is of 3 marks. Okay, you just need to remember the steps and the formulas, then you will be able to do it properly. So transient is basically divided into RL circuit, RC circuit and RLC circuit. In BT you will have only RL and RC, but in FEE you also have RLC. Okay, but the important one is RL and RC. So see, in RL circuit, inductor is there, in RC circuit capacitor is there. Okay, so for this, first of all you need to study about the switch movement, how exactly the switch will work. Like suppose this is the RL circuit and there is a switch, okay, at t equal to 0. They'll write it like this, t equal to 0. So there are three conditions. One is at t equal to 0, one is at t equal to 0 minus, one is at t equal to 0 plus. T equal to 0 is the current situation, t equal to 0 minus just before that. Like suppose you entered the room at 8 p.m. okay, and you close the switch. So the moment which when you change the position of the switch, that is t equal to 0, and just before that, like 1 second before 8 p.m. t equal to 0 minus, and after 1 second of 8 p.m. t equal to 0 plus. Okay, so as you can see the arrow is like this, that means at t equal to 0 the switch is closed, correct, and at t equal to 0 minus the switch is opened, means before that obviously it's open. Now tell me at t equal to 0 plus the switch is opened or closed, tell me. There are two conditions, okay, I told you about this one. There are two conditions. One, the steady state condition, and another one is the transient. Transient means the change in okay, steady state means that will be constant. Like suppose you are at in your lift, so you are continuing, like your first floor, second floor, third floor, fourth floor, fifth floor. That means you are changing the position, so that is your transient. Now you are currently at ground floor and remain in ground floor only for a very long time, so that is your steady state. Okay, so at t equal to 0, at t equal to 0 there is a condition of transient, but because particular at t equal to 0 switch will change. Before that there was a long time that is in the same position, so it's a steady state, and after that also it will be steady state, correct. Means when we change the position of the switch, then in that case there is a position of transient. Got it? Now after that, for any step, for any circuit, step number 1, that we have to draw circuit at t equal to 0 minus. Okay, t equal to 0 minus, as I told you, a steady state, correct. It's a steady state condition, and it's fixed that in steady state condition inductor will behave as a short circuit, the plain wire, and if there is a capacitor it will behave as a one circuit. Okay, I'm writing here, inductor will behave as a short circuit and capacitor will behave as a open circuit, particular at t equal to 0 minus. Okay, next is step number that we have to draw circuit at t equal to infinity. Okay, we have to draw it at t equal to infinity. Again t equal to after connecting the switch after a long time, like suppose you enter the room at 8 p.m. and you switch on the fan, so t equal to infinity as the time passes, 10 p.m. maybe 12 p.m. okay, like that. This is also the steady state condition. The steady state condition, again, inductor will behave as a short circuit and capacitor will behave as a open circuit. So for the very first step, what we need to calculate, if there is an inductor, then we need to calculate current always. Okay, इंडक्टर है तो करंट निकालना है, t इक्वल टू 0 माइनस पे है तो व्हाट विल राइट इट डाउन कि IL ऑफ 0 माइनस, और अगर कैपेसिटर दिया हुआ है तो वी नीड टू कैलकुलेट वोल्ट हमेशा। इंडक्टर चाहे पूछा कुछ भी हुआ हो, ठीक है, कि इंडक्टर है तो शॉर्ट सर्किट रहेगा और इंडक्टर के केस में हमेशा करंट निकलती है, कैपेसिटर है तो ओपन सर्किट रहेगा एंड फॉर द केस ऑफ ऑलवेज नीड टू कैलकुलेट वोल्ट। चेक उन्होंने भी पूछा, गॉट इट, once we'll do numerical then it. So at this stage also, if there is a inductor we need to calculate IL of infinity, and if there is a case of capacitor then we need to calculate VC of, ठीक है। Now after that, step number 3, draw circuit where we have to see t equal to 0. At t equal to 0, tell me it's a steady state condition or the transient condition?
Transient.
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 So in the transient condition we need to calculate tau. Tau is the torque. Again, as you know, there are two cases. If there is a RL circuit, then tau is L divided by R equivalent. And if there is a RC circuit, then tau value is equal to R equivalent multiplied by C. What is R equivalent over here? R equivalent is the RTH. Okay, understood? Now the last and final step. Step number 4. If there is a capacitor, I told you we need to calculate voltage across capacitor, so put it into equation. Vc of t, Vc of infinity plus Vc of 0 minus Vc of infinity e raised to power minus t by 2. All these values we have calculated, like Vc of infinity we have calculated at step number 2, Vc of 0 minus we have calculated at step number 1. So we have calculated at step number 3. But if suppose there is a L circuit, then in that case I told you calculate IL of t. So for that formula is IL of infinity plus IL of 0 minus IL of infinity e raised to power minus t by tau. Okay, write down these steps.
Ma'am, I need
So
to go for 5 minutes. Can I
yeah,
join the call back after 5 minutes?
yeah.
Okay.
But t equal to 0 minus switch is opened, right? Rest of the things
Yes.
same. Now, as I told you in the steps that if there is a case of inductor, then inductor must be short circuit and capacitor must be open circuit, right? So open circuit the capacitor also, okay. And in this particular case, as I told you, what if there is a case of capacitor, what we need to calculate? Vc of 0 minus, correct? So calculate Vc of 0 minus. Wherever the capacitor was there, mark A and B. Okay, so Vc of 0 minus is equal to, understood, calculated.
Ma'am?
In this case VTH is like this. Okay, VAC how much? I into RAC. So I into 18, 10, much, suppose how much current is, consider I2 17, right? EB nothing, no resistor is there. Now tell me in this particular 18, is there any current flowing across it? Yes or no? Current is across 18 ohm. It's an open circuit, and in an open circuit, no current will flow. That is 0 plus 110. I2 is how much? Already given, but we have taken opposite direction because you are moving T2, so current would also move So I2 we can consider as minus 5. Minus 5 into 70. Solve it. Then you will get V minus that is equal to KB, that is equal to BTS. ठीक है? Hmm?
I'm wishing from B to A. Wishing from B to A, right?
We are seeing A to B, not B. Now after that we need what's the step? Step is at t equal to infinity, right? T equal to infinity equal, that means switch is closed because t equal to 0 पे closed हो गया, so equal to infinity also. Switch will remain closed only, correct? Again, diagram. Capacitor will be open circuit, switch is resist as it is, current in as it is. So now this particular case we need to calculate VC of infinity. Again the same procedure, VC of infinity equal to AB and that is equal to, okay? यहाँ से यहाँ गए, इसमें करंट नहीं जा रहा, 0, then back to this path, right? So V of infinity can directly write it down as 110 because you are moving here, इसमें करंट नहीं जा रहा, 110, then blank प्लेन पाथ से आ गए, right?
Yeah.
Understood? After that, number 3. What is step number 3? At equal to calculate tau. Tau is how much? R equivalent divided by, calculate R equivalent RTH. Again, draw the diagram. So particular at transient source must be short circuit. We calculate RTH. For RTH, voltage source must be short circuit and current source must be, tell me, open circuit.
Okay.
So it would voltage source capacitor will be one only and current source. Now this is 80 and this is 70. Tell me, resistors are connected or in parallel?
Series.
Plus 8. So is how much? R equivalent into R equivalent. Got it? Value they have given 5 millifarad. It. Now simply substitute values over here. Okay? So before that transient must
Where have they given?
RTH, and once you get the value for, like, you'll get some equation, you'll get it in equation form, and they said find the time. So this is the equation. Now they have given VC of t, all values you know. Can you get time? Tell me. Of
Yeah.
infinite calculated minus calculate time. What they have asked. I told you whatever they ask this thing. ठीक है, उसके बाद आगे में भी ऐड ऑन करना हो, बट तुम्हें सबसे पहले तो यही निकालना पड़ेगा, राइट? Now see, this is the last module of B, but the second last module of F. Okay, so both BT and FE will have power system. So what is basically a power system? Okay, power system is basically divided into two category. Okay, one is the generation, another one is the transmission, and the last one is the distribution. Okay, so what is basically this? Let me give you one example. Suppose in the Punjab you will have Bhakra Nangal Dam. Have you listened about it? Bhakra Nangal Dam, it's a hydroelectric power plant basically. Hmm? Did you listen about it?
Yeah.
No, ma'am, I haven't.
It's in Punjab. So basically, in Punjab, electricity is generated. Almost 70% of the electricity is generated through hydroelectric power plant only. Okay. So from Punjab, you need to transmit electricity to Delhi. Okay. Punjab, you need to transmit electricity to Delhi. So it's a very long distance. Okay. It's a very long distance. So whenever we'll have a long distance transferring of electricity, that is technically known as transmission. Like you are transferring electricity from Punjab to Delhi, it's a long distance, so that's why it is termed as transmission. And in India, our generation is 11 kilovolt always. 11 kilovolt पे होती है या 33 पे होती है, but maximum time generation in India is at only 11 kilovolt. So transferring 11 kilovolt to Delhi is a very very low voltage, because in this case the losses will be very high. Okay, losses increases and losses will be high. So what we want? We want to increase the losses or we want to decrease the losses? Tell me. Hmm?
Yes.
Decrease.
Decrease. So formula, losses का formula is I square R. ठीक है? Losses का formula is I square R. So from here what we can conclude that if we decrease the current, then in that case losses will also decrease. Yes or no? Hmm?
Yeah.
So to decrease the current, we'll have one formula, P is equal to VI, where P is power and power is constant. If we increase the voltage, then in that case current would be decreased automatically. Correct? So we want to decrease losses, to decrease, then will decrease current, and then will increase voltage. So ultimately increasing the voltage will decrease the current. So here in Punjab we'll use the transformer. This is the transformer symbol. So here we'll use step up transformer. Step up transformer means this transformer is used to increase the or decrease the voltage level without change in frequency. If there is a step up transformer, then it would increase the voltage. If there is step down transformer, then in that case it would decrease the voltage. Okay. So let us consider this one would be 11 kilovolt. By using step up transformer, we increase the voltage up to 220 kilovolt. Fine, up to here. Hmm?
Yeah.
Now electricity is transmitted to Delhi, correct? According to this voltage. Now we are getting 220 kilovolt. Now in Delhi, it is further transmitted to different areas of Delhi, like one in North Delhi, then it will transfer to South Delhi, then it will transfer to East Delhi, and then it will transfer to West Delhi. So it's a very short distance transmission, means Delhi में transfer करना है, so it's a short distance transmission. So technically this term is known as distribution. Okay, technically this term is known as distribution. Transferring for a very long distance is known as transmission. Transferring electricity to a very short, like with short distance, that is known as distribution. Okay, now 220 kilovolt, we don't want such high amount of voltage, right? Like if you know about it at our home, how much voltage we need, how much voltage we are getting through the socket. Do you know how much voltage we are consuming at our home? Tell me. Hmm? Only 220 volt. Remember, 220 say 240 volt. इससे ज़्यादा we don't consume. So see, it's a very high amount of voltage. 220 kilovolt. Again, we'll use transformer, but this time which transformer will use to decrease the voltage? We'll use a step down transformer. Again, it decreased to 11 kilovolt. Now in North Delhi, it was further transmitted, and then in East Delhi, Again, we'll use transformer that is nearby to our home. Again, step down transformer to decrease the voltage from 11 kilovolt to 220 volt. It may be reduced. Now see what they show. I show you the one generation, right? Like in Punjab, electricity is generated. I show you only one generation, but here they have show you two generation. Like there are two power plants. One electricity is generated over here, another electricity is generated over here. Okay, so not an issue. You can show two generation, and then they show that at how much specification the electricity is generated. It's a three phase. Electricity is always generated at three phase. Frequency in India, as you know, we are using 50 hertz, and you know that in India we generate electricity to 11 kilovolt. Okay, so you need to mention that 11 kilovolt, or you can write it down like slash 33 kilovolt. Then they are using this transformer. You can see the two symbols of the transformer, and these two transformer are the step up transformer or step down transformer. Tell me. Hmm?
Step up.
These are the step up transformer, so you need to mention it also. Okay, so now how much we are having, like yeah, they increased from 11 kilovolt to 765 kilovolt. In India, maximum allowable voltage is this one only. ओके, ये इन्होंने बहुत ज़्यादा कर दी, इतनी ज़्यादा हम करते नहीं है. दिस इज द मैक्सिमम वोल्टेज लिमिट, बिकॉज आफ्टर दैट देर इज सम इंसुलेशन प्रॉब्लम. ठीक है, किलोवोल्ट, और वी कैन डू इट एट 400 किलोवोल्ट. तो एक इन्होंने क्या कर दी, 765 किलोवोल्ट, ज़्यादा वोल्टेज इंक्रीज कर दी. एक पे इन्होंने 400 किलोवोल्ट कर दी. ठीक है, या फिर 220 किलोवोल्ट भी कर सकते हैं, 500 किलोवोल्ट भी कर सकते हैं. लाइक दे हैव शोन दैट कि हम कितनी कितनी कर सकते हैं. फॉर गॉट इट. नेक्स्ट, दिस इज टू अदर पूल मेंबर्स, मीन्स जिसको we need high amount of electricity. Like so from Punjab it goes to Jammu पे भी जा सकती है. From Punjab it goes to another area, so that's why they said to other pool member. ठीक है. Now, or they can say that very large customer, जिनकी बहुत बड़ी बड़ी factories mills चलती हैं, so that electricity directly goes to large customer. So okay, now after that it is further divided into फोर पार्ट्स. ठीक है, नाउ दिस फोर पार्ट्स में दिस इज नोन एज ट्रांसमिशन. लाइक यहाँ पे पंजाब है, एंड यहाँ पे अब ये दिस सर्किट इज नोन एज ट्रांसमिशन, की अब इन्होंने इलेक्ट्रिसिटी ट्रांसमिट कर दी. ठीक है, अगेन सब ट्रांसमिशन तुम शो करो ना करो, सब ट्रांसमिशन मीन्स की लाइक पंजाब से दिल्ली आ रही है, लाइक बैंगलोर टू मणिपाल जा रही है. इट्स कि बैंगलोर टू मणिपाल जा रही है, मणिपाल की मणिपाल में ही रह रही है, दैट इज डिस्ट्रीब्यूशन. ठीक है, तो बैंगलोर एंड मणिपाल इज नियर विद ईच अदर, नॉट अ वेरी लॉन्ग डिस्टेंस, राइट. तो वो उन्होंने सब ट्रांसमिशन की फॉर्म में शो कर दी. देन डिस्ट्रीब्यूशन में मीडियम कस्टमर. ओके, देन distribution में medium customer. Primary means which we are using, that is 415 volt 11 kilovolt. तो तुम यहाँ पे 220 volt भी लिख सकते. ओके,